Welcome to another video, a math video. This will be on proving or verifying trigonometric identities. I did one video like this before in my other channel. Actually, I guess it was on this channel, and I better have quite a few more math tutorials on my Tony Payette channel. But from now on, most of my math videos will come from this channel. So please subscribe if they're helping you. I'm going to start by looking at some trigonometric identities or formulas. In the last video on trigonometric identities, I basically used some of the basic or fundamental identities. For example, here the reciprocal formulas that I have here, the Pythagorean identities over here, 8, 9, and 10. And then you have, of course, some other formulas, sum and difference identities for sine of x plus y, or sine of x minus y. Same thing for cosine. And then, of course, you have your double angle identities over here, one for sine of 2x. We have 3 identities for the cosine of 2x here. And then, of course, we have some half angle identities. So some of the proofs today will involve the reciprocal identities. Also be using some of the Pythagorean identities, some difference identities, and also some on the double angle identities. Okay, so let me look at what we're going to do today. Okay, so we want to prove, or sometimes we'll say verify, an identity. So remind you again of what I said last time. When you're going to prove an identity, you're supposed to start with one side and show that you get the other side. So you can start with the left side and show you get the right side, or start with the right side and show that it's equal to the left side. But you never want to work with both at the same time, because it's possible to manipulate both sides of the equation and come up with something that's true when the original is not true. For example, -1 does not equal to 1. Okay, but if I square both sides, this becomes 1, and the other side, -1 squared is 1, and 1 squared is 1. I get 1 is equal to 1. So that's a true statement. But I started off with a false statement. Okay, so the same thing with identities. You never want to assume what you're proving. So when you work with both sides, you're actually assuming the statement you're trying to prove is already true. Okay, so again, the technique for proving identities, generally speaking, you want to start with a more complicated side. There are exceptions, but in general, you want to start with a more complicated side, and you're gonna simplify an expression. You're going to combine 2 trigonometric expressions. It might involve factoring, or it might involve the use of one of the identities that I just looked at. So if we look at this one here, obviously the left side is more complicated. So I'm going to start with the left side. So again, just to save me some time, I'm not going to write it out, but if you were doing this and your instructor was picky on what he wanted, then most instructors would want you to write out the side you're working with. So this is the left side, so I'm going to say LS for the left side. So that's the left side. I would write it out there, and then try to show that that's equal to secant of x. So remember, secant of x is the same thing as 1 over cosine of x. So if I can get this to come out to 1 over cosine of x, then I'm finished. Now obviously I have a 2x here and a 2x here. So obviously I have to come up with functions of just x. I don't want a double angle. So that would suggest some of the double angle identities. Okay, so for sine of 2x, that is the same thing as 2 sine of x cosine. Of x. Okay. come up with secant, I know that somewhere along the line, if I can come up with 1 over cosine, that's going to do it. Okay, so sine of 2x by one of our double identities becomes sine of 2 sine x cosine x. And this is going to be minus. And there were 2, or actually 3 identities for the cosine of 2x. Okay, one of them was 2 cosine squared x minus 1. Okay, and the other one was cosine squared x minus sine squared x. And there was 1 minus 2 sine squared x. So actually, you could actually show this by using at least 2 of those. Now I selected this one, and let me show you in a minute why I selected this one. And again, this is one way to do it. There's another way to do it also, at least one other way. But in looking at this, I see here -1 and a negative over here. So see, these are going to cancel out. So by dividing this out, I can see that right there, that's going to be 1 over cosine of x. But 1 over cosine is this. Of course, for that to happen, some terms are going to have to cancel out. So let's see what we get. Okay, so obviously here, the sines cancel out. So I get 2 cosine of x. Okay, now over here on this one, I'm going to distribute the negative and divide through by cosine. So this would give me minus 2. Oops, let me erase this here. Okay, so right here, I can cancel 1 cosine. So this is going to give me 2 cosine of x. Okay, now in this second part, I distribute the negative, so this negative will make this negative a plus. So that's going to be a plus 1 over cosine of x. And I apologize for the writing here, but I'm trying to do my best to write with this with the mouse. So you can see the 2 cosine of x and the minus 2 cosine of x, that's going to cancel. So this is going to equal, I'm going to have left 1 over cosine of x. Try it again here, cosine of x. Okay, that's an x. But 1 over cosine is secant of x. And that proves the identity. Okay, those are the steps you go through. I'll clear this. And go to the next one. Okay, again, the left side has 2 terms, the right side has 1. So again, the left side is more complicated, so I'm going to start with that. I'm going to say left side is equal to, okay, so this would go right here. Those are the steps. And then look at this, this is difference of squares. Cosine to the 4th, sine to, those are squares. So you can factor this. You can factor this into cosine squared x minus sine squared x times recognize cosine squared x plus sine squared x as one of your Pythagorean identities, so this is just equal to 1. Okay, so what do we have left? We have this expression right here equal to 1. I'm sorry, this expression here times 1, which is cosine squared x minus sine squared x. But if you look at your identities, cosine squared x minus sine squared x, that's the same thing as cosine of 2x. And that proves the identity. Okay. So like I said, in these problems, you're going to combine expressions. One of them could involve factoring, which is what I did here. One of the tricks also that I think I used in the last video that I published on proving trig identities is sometimes multiplying by 1. When I say multiply by 1, I mean multiply by an expression that's equal to 1. For example, cosine of x plus 1 over cosine of x plus 1. And that might solve the problem for you. Clear this. Okay, this one here, you could go either way with this one. You could use the formula for the cosine of x minus y. Cosine of x minus y is cosine of x, cosine of y, plus sine of x, sine of y, and then divide through by the bottom term, and you'll find that this answer comes out fairly easy. Or you could just start with the left side. I'm sorry, the right side. But you can also do the right side and say this is equal to, and then just write this. Okay, so we know this has to come out to this. This side over here has cosine and sine, so that would tell me then I need to rewrite these. So tangent of x is equivalent to sine of x over cosine of x plus, and then cotangent of y is equivalent to one of your identities, cosine of y sine of y. Okay, so these are two rational expressions, trigonometric expressions. So this is just basic algebra combining, finding my LCD. So if I find my LCD, obviously it's going to be cosine of x sine of y. Okay, so that's what I have in the denominator, and look, that's what I need over here on the left side. Look, cosine of x sine of y. Okay, so that pretty means that means then that the rest of it should come out by the terms that I have up here. So this then just multiplies, cross multiply to get the top part here. So this will be sine of x times sine of y plus, and then these two get multiplied, so that'll give me cosine of x sine, sorry, cosine of y. Okay, so you can rewrite this and say, okay, the top part can be written as cosine of x cosine of y plus sine of x, sine of y. So cosine of x, cosine of y plus sine of x times sine of y. But that's the same thing as cosine of x minus y. Okay, and that was one of the identities that from that list. Okay, so in the bottom then I would just have cosine of x sine of y, and that proves it. Okay, so just a matter of rewriting tangent of x as sine of x, cosine of x, cotangent is cosine of y over sine of y, and using basic algebraic techniques to combine that over a common denominator, and we get the result. Okay, let's look at the last one. Again, the left side here is the more complicated side, so I'm going to start with the left side. So, okay, the left side is equal to, okay, so I have to come up with sine of 2x. So over here I have functions of x, over here I want functions of 2x. That's okay, we go ahead and rewrite this, and since we have to come up with a sine, we can rewrite tangent in terms of sine. So on top, tangent of x is the same thing as sine of x over cosine of x. Okay. Now 1 plus tangent squared x. Remember, this is over here, left side. So all I did is rewrote the tangent of x as sine of x over cosine of x. And then in the denominator, 1 plus tangent squared x, that's one of your Pythagorean identities. That's the same thing as secant. Oops, let me see. That's the same thing as secant squared x. Okay, so now let's go again. This is 2 then sine of x over cosine of x over, and secant squared x, using your reciprocal identity for that, is the same thing as 1 over cosine squared x. Okay, then rewriting this, I'll get 2 sine x over cosine of x. And then here we're dividing the fraction, so we just inverted multiply, so this will be times cosine squared x over 1. Okay. Now, here I can do some cancellation. Cosine x here and cosine squared x over here, so I'll put it equals up here and say this will be 2 sine x. And like I said, one of these will cancel, so I'm going to be left with 1 cosine x. But 2 sine x cosine x, that's the same thing as the sine of 2x, are your basic identities. Okay. So those four identities that I went through. You've seen some of those identities that I listed, showed you at the beginning of the video. So I hope this helps, and if these videos are helping you, please subscribe to my channel, and we'll see you in the next video.